Today is April 23rd, and we're going to do Unit 12, Lesson 3, and we're only going to do pages 406 through 409 today. That's the first half, and your homework is on page 414 through 415. Only do questions 1 through 8. So today on Lesson 3, we're going to be adding probabilities, and we're going to talk about something new called a two-way frequency table. Sometime we're going to talk about a couple events. First of all, we have an event A, we have an event E, and we're going to figure out the probability that one happened or the other happened. To do that, we have to look at everything that falls into either one of the two events. So we're going to look at Venn diagrams. Here we have a spinner. So if you spin it once, we have 8 numbers, and let's let A be the event of landing on an even number. And B is the event of landing on a prime number after one spin. So what are the prime numbers? Prime numbers are 2 and 3 and 5 and 7. And what are the even numbers? 2, 4, 6, and 8. And there's one that's in common. The 2 is in common, so we'll put that in the middle. And then all the other even numbers, 4, 6, and 8. And all the other prime numbers, which are 3, 5, and 7. And the only one that we didn't account for is the number 1. So what we have is we have this new vocabulary word called union. Union is abbreviated with a U for union. Intersection is an upside down U. So those are their abbreviations. Union means or. Just remember, union is or. Intersection is and. It's just an abbreviation, and I always remember intersection because this upside down U, if you just put a little line across it, it would make the letter A. So A for and. So that's just a little trick that I use to remember that this means and is an intersection. Union is everything all together. Intersection is only those elements that two things have in common. So here is just a definition. Union is A or B, like I just set up here. The U is the abbreviation that means the set of all x values, that x is either in A or it's in B. So it means everything that's in both of those bubbles, including the middle part. The intersection, which is an and, that was like what we learned yesterday. It's that middle part. This middle part is the and, or is the whole entire part. So what we're going to do is we're going to look at this exercise above, and we're going to do A or B, the union. So A union B is everything that's in both A and B. So that would be, and it doesn't have to be in any particular order, so we can just do 4, 6, 8, 2, 3, 5, and 7. Sets don't have to be in any particular order. A and B, the intersection, A and B, is just the number that they have in common, and that is just the number 2. So from exercise 2, why is the equation n for number? How come the number of elements in A or B, so count them, 1, 2, 3, 4, 5, 6, 7, how come 7 is generally not equal to the number of elements in A, which are 1, 2, 3, 4, plus the number of elements in B, 1, 2, 3, 4. 4 and 4 is 8. 8 doesn't equal 7. Why isn't it true that the number of A or B altogether is just adding them up? And the reason is because you have an overlapping set of numbers sometimes. So often there is an overlapping element, or 2, or 3. But there are sometimes, if there are numbers in here in this and, then you would be double counting the 2. So the formula for the union of two sets, a formula for the number of elements in the union of two sets, A union B, the number of elements is equal to the number of elements in A plus the number of elements in B, and then you have to subtract out the number of elements in the intersection A and B. That's when you're talking about the number. And we're also going to talk about probabilities, and we're going to use the same exact formula, except instead of the n's, we're going to put P for probability. So on the back, we're going to talk about a little example where we have a set A and a set B. A represents all Americans, B represents all people in the whole wide world that have brothers. So here's the set of Americans. Here are the set of people in the whole wide world that have brothers. These are the people right here that are American and have brothers. This here, this is the or part, the or. This means I select a person and they either are American or they might have a brother. So that's written A union B. And we can find probabilities or we can find number of people. They're both very related to each other. And so now we can also find out the set who are not Americans. Well, here the Americans are in white, and everybody that's not Americans, that's the complement of A, which is also written AC, or it can also be written as not A. You can see it written couple different ways. So that's not A. Oh, here it says it's written A complement. Or probability, if we're talking about probability that a randomly selected person is not American. So that's page 407. Moving on to page 408. Now we're talking about a car dealership. Let's say we're going to maybe the Honda dealership or the Ford dealership. So let's think about all the cars on the lot. We're going to select a car randomly in the whole lot, and maybe a car has manual transmission. That means like it has a stick shift. So manual transmission, let's denote that with the letter M. And let's say all the sedans on the lot, sedans are like family cars, they're going to be called S's. And some sedans have stick shifts. Most of them don't, but some of them do. So here's a Venn diagram, and these show the probabilities. You can tell they're probabilities because of the decimal values. So what we're going to do is we're going to complete these sentences using either the word and or the word or. And so that just makes you understand what this symbol means. This upside down means intersection. And remember, if you draw a little line through it, it could be an A. So this is M and S. And remember, and is the part that's in the middle of the Venn diagram. So the probability that a randomly selected car has manual transmission and we're going to select the word and is a sedan. That is the intersection. What is the value of that? Well, that would be 0.12. That's the part in the middle. Now we're going to complete the next sentence using either the word and or. So here's the union. The probability that it's manual or a sedan is the probability that a randomly selected car, pick any car in that lot, what's the probability that it's going to have manual transmission or is a sedan? And what's the probability of manual or sedan? Well, all you have to do is add those three numbers up. 0.09 plus 0.12 plus 0.6. That should be equal to this is 0.18. No, this is 0.72, sorry, because that should be 0.60 here. So that would be 0.81. Another way you could get the value of or is you could take 1 minus this number on the outside here. This is the neither nor. Neither M nor S is on the outside. So you could say, there's another way of getting it. You could say 1 minus the neither nor part of this, and that would also give you 0.81. So either way is fine. Doesn't matter which you use. This one says, what's the probability of the complement of S? Remember, the complement is everything outside the letter S. So this letter S is 0.60. I'm going to put a little 0 here to make that easier. 0.60, 0.12. That's the sedan. So everything on the outside. So 0.09 plus 0.19. 0.09 plus 0.19, that's 0.28. That is outside the S circle. Circle with a C. That is the complement. That means not S. And what is the meaning? Oh, we just explained it. It means the probability. Remember, these are all probabilities. The probability that a car randomly selected will be, well, will not be, I should say, because it's the complement, will not be a sedan. That's page 408. And then moving on to page 409, we're going to talk about something called a two-way table. So this is a two-way table here. It's called a two-way frequency table. So there's another vocabulary word that you need to know. And this is how events or sets can combine. We're going to look at the union again, or overlap, looking at the intersection. And what we're going to do is we're going to talk about this particular situation at a small high school. Let's say the small high school has 52 seniors, and there was a survey, and they said to all 52 of the seniors, what do you plan on doing after you graduate? And so they took the survey. Some were going to college and some weren't going to college. And then they broke it down by male and female. So if we pick a student at random, we can get a probability that, for example, a student is going to go to college. So we're going to call M for male. We're just going to abbreviate males with an M, females with an F, C for going to college, and N for not going to college, just to make it a little faster. And so what we're going to do is give the values of the following. Now N, remember, N means the number. How many males? This is the number of males. We'll go over to the male column. We have 16 males going to college, 14 males not going to college. We have a total of 30 males in this. What are the number of females? Well, 13 are going to college, 9 are not going to college. So we have a total, right here, there's a total column of 22 females in this class. So this says how many males and going to college. Well, you look at the male line and look at the going to college line. How many males are going to college? There are 16. 16 males, and M and C means males and going to college. What about the number of females that are going to college? Well, here's the female column. Here's the college row. So there are 13 females and going to college. Now, what about, over here, what about the number of people going to college? Well, let's look across the college line. 16 boys, 13 girls, 29 total are going to college. And not going to college, 14 boys, 9 girls, a 23 total number of people not going to college. And now, how about females or going to college? So you've got the 22 females here, or going to college. Well, you wouldn't count this 13 twice because you've already counted it here. Well, we can use that little formula that we wrote down before on page 406, the number of formula for the union. So this would be, what are the letters, F or C? So the number of females plus the number of college students minus the ones that are and. So the number of females plus the number going to college minus the number of females and going to college. And we've got all of that information that we've already done here. This is F and C, if you want to put this abbreviation down here for letter VI, and this is the number of males and going to college. So this is the number of females or, and I don't like that, so we're not going to abbreviate that one. So the number of females is 22. The number of college students are 29. And the number of females and college students, that is 13. So 22 and 29, 40, 51. 51 minus 13, 41, 38, I believe. So there are 38 people. I hope that's the right number. I did that math in my head pretty quickly. So the probability that a person picked at random would be female who is going to college. Now we're going to talk about probability. All of these are the numbers, N. Those mean numbers. Now we're going to talk about probability. What's the probability that a person at random is going to be a female who is going to college? So what is the probability that there is a female who is going to college, that would be the and, is going to college? Well, we already have the number of females who are going to college. That's 13. Now, what about the probability? Well, there are 52 people in this whole senior class here, so the probability that you select somebody at random, there are 13 of those females going to college out of a total of 52 people in that senior class. Part C says, what is the probability that a person picked at random would be female or somebody going to college? So what is the probability that somebody's going to college or is the union college or female? And remember, college or female is the probability that, well, we've already figured that out up here. There are 38 of those. So 38 of those students out of a total of 52 students in the same class, the senior class, that's the probability that they're female or they're going to college. This is the female and going to college, a lot less than the or. Why doesn't F or C equal the probability of the females plus the probability of people going to college? Because you would have females double counted. The 13 females who go to college would be double counted. Right? If we added all the females together, which would be 22, all the people who are going to college, which would be 29. If you add 22 and 29, you've got 51 people already. Well, we're not talking about 51 people. We're only talking about 38 people. So that would mean that you would have to subtract out that 13 who would be double counted. Double counted means you would count them in the row and the column both. And so the probability of A or B, we already wrote it up here, that is the probability of A plus the probability of B, and you can subtract out the probability of A and B. So these are probabilities, these are numbers of. And so sometimes we can avoid the probability of law. Oh, I'm not sure I'm going to read that. I'm just going to go right to the exercise here. Let's say we have a die, we're going to roll it once. We're going to find the probability that when we roll the dice, we're going to get either an even or a multiple of 3. We're going to represent it as a Venn diagram. So we draw our big old rectangle here. We're going to have a circle here that represents the even numbers. We're going to have a circle here that represents our multiples of 3. And even numbers are 2, 4, and 6 on a die. Multiples of 3 are 3 and 6 if you represent it on a die. So there's a common number here, that's a 6. And the other even numbers are 2 and 4. And the multiples of 3 are 3. And I don't think we've represented the 1 or the 5. So they would go out here. 1, 2, 3, 4, 5, 6. So here's the Venn diagram. And what we're going to do is we're going to figure out the probability that it's either an even number or a multiple 3. But what is that probability formula? It is the probability that it's an even number plus the probability that it's a multiple of 3, and subtract out the probability that it is an even number and a multiple of 3. Well, what's the probability that you're going to roll an even number on a dice? Well, you've got 3 even numbers out of 6 possible. What's the probability that you're going to roll a multiple of 3? Well, you have 2 of them out of a total of 6 different possibilities on a die, and you're going to subtract out the and. This part right here is the and. How many elements are there in there? There's only 1 element out of 6. So when you add these up, 3 and 2 is 5, minus 1 is 4, so you have a 4 and 6 chance that you're going to roll either an even number or a multiple of 3. And then we have a last example exercise here. We're going to talk about an insurance company today. Insurance companies sell a lot of different types of insurance, but this particular one sells car insurance. 56% of all their customers have car insurance, And they also sell homeowners insurance. 48% have homeowners insurance, and some of those customers have both. So we're going to pick a customer at random from this particular insurance company, and we're going to find the probability now, probability, not numbers, probability that he or she has at least one of the policies. Well, if they have at least one of the policies, we'll call C for car insurance, we'll call H for homeowners insurance. And what is the probability that they'll either have car insurance or they'll have homeowners insurance? Well, that's the probability that they'll have car insurance plus the probability that they have homeowners insurance minus the probability that they have both car and homeowners insurance. Well, from the numbers that we have up here, we have 0.56 plus 0.48 minus 0.18. Let's see if I have that number handy. No, I don't. So let's just see, 48 minus 18 is 0.3, and 0.3 plus 56 is 0.86. So that is the probability that they have one or the other. What is the probability that she has neither of the policies? Well, if you remember about the neither is on the outside of the Venn diagram. This would be 100% minus the probability that they have either car insurance or homeowners insurance. Well, that would be 1 minus, we just figured that out, 0.86 would be 0.14. Now you can also draw a Venn diagram for this particular example if you want to. So I'll just try to draw a small one. You might want to try to draw a small one over here. Let's say here's our car insurance policy. Here's our homeowners insurance policy down here. And the car insurance policy was, there were 0.56, 56% of car. Homeowners, do our little lollipop thing, homeowners 0.48, and 0.18 is the number of customers that have both. So you can just subtract 0.56 minus 0.18 in the middle, which would be 0.38, because this plus this has to add up to the 0.56, and then 0.48 minus 0.18 is 0.30. So if you add up 0.38 plus 0.28 plus 0.30, you're going to get 0.86. So that's another way you could do it. And then if you remember on the outside, this whole thing has to add up to 1 for probability. So on the outside of this Venn diagram would be a 0.14, because 1 minus all three of those numbers would be equal to that. So that's all there is today, and I hope everybody's doing well, and I hope I didn't go off the page too much today when I did this video. But you can stop it and slow it down, rewind it, send me a chat if you have any questions, and we will talk to you again soon.